Hello everybody and welcome to today's webinar. Thank you for joining us. Thank you if you logged in early. Sorry for the little bit of delay to get started. As normal, I always try and wait for as many people as possible to log in. As you can imagine, everybody tries to log in at the same time on the hour, and there's people still logging in now. But thank you once again for joining us today. And as you know, today's session is on instrumentation and source control, time to act. Today's presenters are Cary Millsap. You can follow Cary if you're on Twitter at Cary Millsap. Cary's an Oracle ACE director, co-founder of the Oak Table Network and founder of Method R Corporation. As always, I'm James Murtagh. If you're on Twitter, please follow me at All Things Oracle. I'm part of the Oracle Tools team at Redgate and the creator of allthingsoracle.com. Today's webinar is brought to you by Redgate and Method R. I hope you had a chance, if you did log in early, to check out the websites. If not, we can share those URLs at the end. So before we get going with the main part of the presentation, just a few things. Everybody will be on mute for the duration of the event. Hopefully my sound's clear. Those of you that have come to regular sessions might have seen me struggle with sound. If any time the sound does go a little bit weird, please do let us know through the chat box. Obviously, check your own settings first. There will be a Q&A session at the end, but please type your questions in the question box in advance. This session is being recorded, and a full recording will be put up online afterwards. So just a little bit about Redgate and Method R. If you've heard of Redgate, that's great, and I hope you've had a chance to check us out. If you haven't, then Redgate, we're primarily a database tools provider. Over 600,000 technology professionals worldwide use Redgate's software, including 93% of the Fortune 100 companies. There's some logos on the screen here, so as you can imagine, all of the major companies are using Redgate's products in one way or another. The reason that our products go down so well is our philosophy is to design highly usable and reliable tools that solve problems commonly faced by DBAs and developers. Our Oracle tool suite have three main tools that fit into the deployment suite for Oracle. We've got source control for Oracle, which we'll be looking at throughout this presentation, schema compare for Oracle, and data compare for Oracle. The tools have been designed to make deploying databases easy. And I've got a little quote here from a user and actually a fellow ACE director, Cary, about source control. Just going to pass over to Cary now to tell you a little bit about Method R.
Good day, folks. Cary Millsap here, and I'm wondering what happened to one of my logos. But anyway, Method R is a software and education and consulting company that helps database administrators and developers make faster applications faster. We have three primary products. The Method R Profiler, and that apparently flag set of rectangles, alien symbol, circle with a square behind it, says Profiler in some language that I'm unfamiliar with, but that's the Method R Profiler logo. We have Method R Tools and Method R Trace. Again, we have a quote here at the bottom. This is what we try to do. We try to provide tools that are delightful for people to use, teach them how to use it, and then when folks need help with performance issues, we have the consulting staff that can help out with that. Next slide, James. And there are two books available now on Amazon. About 3 weeks ago, there's only one. Many of you have heard of me, might have kind of learned about me through this book called Optimizing Oracle Performance, which was published about a decade ago by O'Reilly. The content of that book is still relevant. A few things have changed in the Oracle kernel since the book was published, of course, but most of the basic instrumentation that the book describes is still exactly how Oracle does its work. So I think the book on the left is still relevant. About 2 weeks ago, we self-published, actually through CreateSpace at Amazon, the book called Mastering Oracle Trace Data. And this is actually the official course book for the Mastering Oracle Trace Data course that I teach. Enough people outside the course asked for the book that we went ahead and published it. So if you're interested, either can be obtained at Amazon.com. And back to you, James.
Thanks, Cary, and I apologise for the logo. I pulled the slides up on a different machine, and obviously it didn't have that logo installed, so I do apologise for that. Okay, so just to outline how this session is going to go, I'm going to give a very quick introduction to what we're going to be talking about, and the webinar is split into two. They do fit together, though, in the context that these are two things that a lot of people know they should be doing, and maybe they've heard that they should be doing, but they aren't necessarily doing. And that's instrumenting your code, which Cary Millsap's going to go over, and source controlling your database code, which I'm going to go over before the Q&A at the end. So as I've just mentioned, there are two things that people are often aware that they should do, but they don't, and that's instrumenting their application and source controlling their database. The aim of this session is to give you some examples or some pointers, really, of why you should be doing these two things before showcasing Redgate tools and Murtagh tools that can be used to make both instrumenting and source controlling code easy. So hopefully by the end of the session, you'll learn what's available to help you do both of these things. I'm going to pass over to Cary now, who's going to go through the first part of the webinar, which is on instrumenting code.
Very good. We'll do our little switchy swappy here. All right. And let's see, one more click and I think we'll be ready to go.
Okay, looks good, Cary.
All right, James, thank you very much. My section is about instrumenting your code. And it begins with this. This is a slide that, as I was preparing for this presentation, I went through a bunch of things that I've presented to different audiences. And this slide actually comes from a presentation that I've done for college students who are computer science majors. And you can see there's a bunch of janitorial supplies being shown here, and I'm trying to kind of conjure up that there's a bunch of stuff that may not seem too glamorous that computer science majors, I think, in school tend not to really focus on. But in order to do software development for a living, you really have to be good at these four things. You have to be good at writing a test, running a debugger, using a version control system, and running a profiler. And I've been saying this for a really long time, and I think that schools tend not to focus on these things, and I think that that's possibly why a lot of people in the business world tend to not focus on these things too much. They just sort of come in on demand. You know, people realize they have a problem that needs to be fixed, and then they sort of discover something in these four categories. And of course, this matches really well with today's topics, because topics 3 and 4 are exactly what we're talking about today. So I'll start with this really hideous picture. Distributing code without profiling it first is like cooking without washing your hands first. It's really just an ugly idea that you might infect thousands of people who will use your software with mistakes that you've made that would be easy to find if you were to profile, but are not easy to find until a lot of your customers have to go out and discover these problems themselves. And I always come back to a quote from one of my heroes, Donald Knuth, who many years ago said that the universal experience of programmers who have been using measurement tools has been that their intuitive guesses fail. In other words, people have a really difficult time knowing where their code spends its time. And when they look at their code, they almost always guess incorrectly. And I fall into that category as well. I try to do it too. When I look at my 7,000 lines of code and try to figure out what should I tune today, I'm always wrong if I just look at the code and try to guess. Whereas I'm always provably right if I can actually profile my code and find out where its time is gone. So what is profiling? Well, a profile is a tabular decomposition of response time. The example shown here is a profile for a 49.699960 second experience. And the reason that number is red at the bottom of the table is because that's the most important number on the page. That needs to match the experience that you're trying to diagnose. And if it does, and if the numbers above it add up to that number, then you have the clues that you need to go solve the performance problem of why did this thing take so long. And as you can see here, 81.5% of this 49.699,960 seconds was spent doing this thing called SQLnet message from client. So armed with this information, now we go figure out, well, what does SQLnet message from client mean? Why does my code do it 18,585 times for a total duration of 40 seconds? And we're off. The diagnostic process after this is fun and interesting and usually not very slow. So a profile really is an invoice for response time. It's just like when your child or your spouse goes to the Apple store and brings home way too much stuff, and the performance diagnostic process begins with looking at the invoice. What all did you get? Oh my gosh, we don't need this. We do need that, but it's too expensive. We need to find a cheaper one, and so forth. So a profile is very much like an invoice for response time. Now, how do we do this? Well, it begins with instrumentation, which is the topic of today's session. This is just it looks like C code, and apparently somebody's written a fast Fourier transform, and they want to know how long it takes. Well, kind of the first swing at this, how long does something take, begins with the top line of code that I've added. This T0 equals current time. That's instrumentation. We want to know what time it is before we do the fast Fourier transform, and then the T1 equals current time after the fast Fourier transform. That's what time it is at the end of doing the code, represented by the comments in the middle. Now the top printf simply writes out to some file. This would write to standard out that the formatted time T0 is what time the FFT began, and the bottom printf would show what time the FFT ended, and then in parentheses, if we subtract T1 minus T0, we can see how many seconds were consumed by this fast Fourier transform. So normally, people would write code that does the fast Fourier transform, but to instrument this FFT code, somebody simply is seeing what time is it, print that out, do the thing, what time is it, print that out, and then print the subtraction of those two time values to see how long the thing took. So if you do this several times, maybe there's several pieces of code, not just your fast Fourier transform, but lots of other places in your code that you'd like to collect information about time, you start to think about refactoring your code. And kind of the logical conclusion of refactoring is what I'm calling instrumentation version 2. What we want is as little effort as is necessary on behalf of the developers to actually do proper instrumentation of the code. So it's probably pretty easy to see how the prior page can be factored into the code on this page. We basically call a function that says start task, call it FFT, and then when we end task, we don't even have to really name the task because we're just popping a stack at that point. So you can kind of envision behind start task as a timer call, maybe a print to some log file someplace, and the end task is a pop of a stack to pop the name off, a timer call, and then probably a print to some log file. And maybe there's a switch that the print to a log file is actually enabled by consulting some global variable or some table or shared memory segments or something like that. So instrumentation, if you just do it for a little while, it tends to start looking a lot like this page here. So that's how you instrument code that you write yourself. But the question is, how do you profile an Oracle experience? And it really has 3 steps. There's an instrumentation step, a tracing step, and then a formatting step upon the trace data so that you can read it. The instrumentation step looks mostly like this. Pretty much in Oracle, all you have to do is name your tasks because Oracle has machinery built into it that allows you to do tracing for named tasks. There are a couple of categories that you need to understand. There is the concept of a client identifier that you can set as a developer. You can set by calling dbms session.setIdentifier and just pass it a string. If you're writing your code in PL SQL, that's the way you'll probably do it. If you're writing Java code, then there is a function called set end-to-end metrics, which has been shipped with Oracle ever since release 10G. And if you just look up in the manual, the Oracle OCI guide, for example, this OCI ATTR set function, you'll see all these attributes that you can set, like client identifier, module, action, and several others. And the set end-to-end metrics Java method is an extremely efficient, high-performance way of setting everything that Oracle needs to know in order for you to be able to trace later. Now the second category of things under my Name Your Tasks bullet shows service module in action. And this is a standard hierarchy that Oracle uses to allow you to identify tasks. So for example, your service name might be the financial service. The module name might be Oracle General Ledger, and the action name might be posting. So you can set the module in action with a single PL/SQL call to dbms application info.set module, or again, if you're using, for example, Java or anything that connects to the database through OCI, you can use the set end-to-end metrics method in Java with the OCI attribute called module set. So you can do all that, or kind of version 2 of instrumenting. We've kind of encapsulated all this stuff and put it into a library that's available free of charge from sourceforge.net, and it's called the METHODR Instrumentation Library for Oracle. We abbreviate it ILO. And this page looks a lot like that Instrumentation V2 page that I showed you previously. You write your code to perform whatever task you want to execute, and then before it, you simply call this ILO task module's begin task function with a module action name and optionally a comment. And at the end of the code that you write, you call ILO task.end task, and you're done. All the things that I showed on the prior page get done in addition to a bunch of other stuff that also happens too. Fully open source, fully free, so I encourage you to go. URL is methodr.com/software/ILO. And do please look up the set end-to-end metrics method call for your Java code. It's in the Oracle documentation. And if you're curious about how it gets used, the new book that I pointed you up to at the beginning of the introduction also contains additional information about that as well. So that takes care of the instrumentation phase. The next phase is the tracing phase, the T in the little flow chart on the bottom. So Oracle provides a standard package in PL/SQL called dbms monitor, which contains a function within it called session trace enable. There are lots of other functions as well, like serve mod act trace enable, that allows you to create a standing order that any time a task runs with a given service module and action name, those things can be traced too. But this is the simplest one, and this allows you, if you know somebody else's session ID and serial number, you can trace them, or if you supply nulls for the session ID and serial number arguments, then you'll trace yourself, which is what most developers want to do. We also have a tool called METHODR trace. And let me see if I can get out of this and show you what METHODR trace looks like really fast. It'll be my version of a tiny little demo. What you can see on your screen here is SQL Developer with METHODR trace enabled, and you can see in the button on the bottom right-hand side of the screen there's a button that's been depressed that says Mr. Trace enabled. And what I've done here is I've run a query against my database that I'm connected to. I've said select star from DBA extents or row nums less than 500. And when I ran that by clicking on the little page with an arrow on it, it's the little run script button there at the top, what happens is that this particular SQL that I've written runs, and then Mr. Trace automatically downloads a trace file that corresponds with that query into the SQL Developer table here at the bottom. This little local trace files tab at the bottom is the Mr. Trace add-in to SQL Developer. And what you can do with this trace file, you can open it with whatever application you like. And the application that I've opened this file with is called the METHODR Profiler, which I'll show you on the next page. I've got another slide to show you before I go to this. But basically, if I want to run something, I'm going to do something real quick here that'll happen very quickly. So I'll select the word hello, all things Oracle from Dual. And then when I run that by clicking this guy, I'll get the output. And then you can see I got a brand new trace file here, and if I open it just by double-clicking, my default application is MacVim. And the file that opened up, you'll actually be able to see, if you look through here, the select hello all things Oracle from Dual that just occurred. And I know the screen refreshes are slow because I'm showing so much data, but let's see, it just snapped into place on my iPad. So you can see that this is actually the trace file that I just created. And that's how easy it is to get a trace file with the right tools. You basically do what you were going to do anyway. The file automatically shows up on your desktop, and if you want to open it, it's just a click away. So that's the point of the METHODR trace tool. Let me go back to the slides now, and I may have to switch my screen again. So let me do that. All right. So once you've traced, the next step in the workflow is to format that trace data, because nobody wants to have to hand analyze what I just showed you in my Mac Vim window. So there's several ways to do that. Oracle created a tool more than 2 decades ago called TQF, which does a little bit of work on the trace file for you. Carlos Sierra is a friend of mine. He's the author of a thing called Oracle Trace Analyzer. And he actually has a great testimonial about our METHODR profiler at the methodr.com website. Carlos is a METHODR profiler user in addition to using his own tool. Then there are 2 sets of tools, METHODR tools and the METHODR profiler, and this little icon here is to remind me that I have a quick demo of that as well. Our goal, and I'm going to go ahead and stop the slides, and I'm going to go show you the browser page that represents the profiler output. So this thing that I ran a while ago that returned 500 rows from DBA extents created a profile report, which is an HTML document that looks like this. And I'm not going to go diagnose the whole thing in front of you, but basically what I wanted to show you is that this experience that lasted 2.6 seconds when I ran the query through SQL Developer created trace data that explained why it took the 2.636 seconds that it did. And the table that you're looking at here that says profile by subroutine is telling me that, inconveniently enough, 40.6% of my time was spent unaccounted for. That is, that the trace file doesn't really explain, but it does show that time elapsed, but it doesn't say why the time elapsed. And this is typical of what happens when you run SQL on a really heavily loaded machine that's sort of not got enough CPU capacity to really run what you're asking it to run. And at the time I ran this, I had GoToMeeting open, I had QuickTime open, I had the profiler open, I had 20 tabs in Google Chrome open, I had Adobe Illustrator open, I had a virtual machine running an Oracle database open. So on this machine, this is the kind of profile you're going to tend to see when you run SQL that takes a while. There's a lot of the task is trying to use CPU, but it just can't get to it because it's being used by so many other people. So even problems like that can be identified, and you can prove positively that this is the kind of thing that's going on when you see profiles with this kind of a pattern. Now, this document's huge. It's got lots of stuff in it. The profiler does lots of work. Basically, your pathway through this document is by finding the things that consume the most time. Like, for example, the alternative view of this 2.636 seconds is that one SQL statement, the select star from DBA extents, took 90.9% of our time. So I can drill into that simply by clicking the stats button, and I can see exactly why this thing took the time that it took. So that's the profiler. I'm going to go back to the slides here and give me a couple of clicks. I will have to re-swap this place. And that's how I profile an Oracle experience. If I'm acting in the role of a developer, I run my SQL or PL SQL package in SQL Developer with Mr. Trace turned on. I get my trace file automatically. I don't have to FTP anything myself. I don't have to go look for the file. The file just shows up automatically on my desktop. I click it to run the profiler. I download it into a file system directory to run my tools on it, and I can go to town. The key thing here to understand is that feedback is the basis for improvement. And every single tool on this page, I can name them all. I've got most of these things in my house. This thing on the top left is called an Eichner distometer, and it's a really high precision tool, which I do not own, by the way, for measuring distances from this little shaft that you see on the right to the bottom. The cheap version of that, the next one over, I do own. This tells me how high a bit is set, for example, on my router table. Instead of doing trial and error, I can get feedback from a measurement tool fast and easily, quickly and easily, that tells me exactly whether I'm on plan or not. And every one of these devices on the top row is a similar measurement tool that you might use in a shop. On the bottom left, you see a Dyson vacuum cleaner. And these Dyson vacuums really, I find this phenomenon of Dyson's popularity to be really interesting. And I think that the reason that Dysons are so interesting to so many people, A, they do work really well, but B, they've got a clear chamber so you can actually see the crud that this thing is doing. You can see the work that it's performing without having to guess. The dust collector next to it has the same thing. It's got a clear chamber that makes it a lot of fun to use the tool because you can see everything that goes through this thing. The rest of the stuff on the bottom is stuff that my kid uses in baseball. And if you really want to know if you're catching properly, for example, you use this flat glove that forces you to use both hands. It gives you feedback instantly if you're doing it wrong. Now, long feedback loops kill. Imagine how bad it would be if touching this took 30 days to register in your brain. Imagine the harm you would do to your body if you didn't know nearly instantaneously that you were burning yourself. And now I'm going to ask you, think about how many times you've waited for maybe 300 or 600 days to learn that you've designed a bug into your software. Well, this is what happens when we don't instrument our code. Without instrumentation, we build a bug in January that we may not find until 15 or 18 months later when that code goes into production. However, if we instrument the code, we can actually test it more completely by observing what the instrumentation is telling us early in our tests. And it also makes it easier in production later to fix bugs that might have passed through the filter. There's nothing more difficult than writing some code, having somebody call up and saying that your code is way too slow, and having no instrumentation in there to grip onto to try to figure out, well, which part of the code that I wrote is slow. If your first move is to guess, then the project is going to take a lot longer than if your code were able to tell you exactly where your time had been spent. This is important because, as most of you have seen, I think most of you probably have seen the graph on the right that shows how the cost to fix an error increases exponentially as we go deeper and deeper into the software development lifecycle. The graphic on the left is the barrier. This actually comes from a book called Software Engineering Economics, which I'm remiss, I should actually credit this picture. So, Software Engineering Economics by a gentleman named Barry Boehm. And it shows what looks like a line that represents the cost of fixing bugs deeper into the software development lifecycle. But if you notice on the left-hand side, the relative cost to fix error axis is actually logarithmic. So if you take this line on a log scale and plot it on a linear scale, it turns into the hyperbola on the right. It's actually not a hyperbola; it's an exponential curve. And that, folks, is why we wash. So to sum up, before I pass back to James, instrumentation and profiling has a lot of benefits. Basically, it saves you money, it saves you downtime, and it saves you frustration. The Oracle database really does help you along because it is beautifully instrumented internally. All you have to do is learn how to turn it on. But that turning it on has been traditionally manual and difficult. You have to do a little bit of work in your application. When you generate the trace data, you have to be very careful when you turn the tracing on, when you turn the tracing off. If you make a mistake on that, you end up with a problem. And then you have to go find the file. Well, with tools, none of those things are a problem. You can do these things very quickly. And for the curious, I encourage you to follow up by visiting us at methodr.com. And also have a look at Amazon of the book called Mastering Oracle Trace Data. With that, James, I'll of course be here for the rest of the show for Q&A and stuff at the end as well. But that's it for me, and back to you.
Thanks, Cary. Your sound did go a little bit funny after you said visit us at methodr, so we missed the last bit of your presentation.
Very good. I just said visit us at methodr, and if you're curious, I hope you'll take a look at the description of the Mastering Oracle Trace Data book at Amazon.com.
Great. Thanks, Cary.
Thank you.
So I hope that gave you a good understanding of the reasons why you should be instrumenting your code. I know there's some questions that have come in already, which is fantastic. So I'm now going to move on to why you should source control your database as well. And I hope some of the things that you'll hear me say are kind of quite similar in a way to what Cary was saying. So I'd like to consider a potential scenario. So we've got two developers that have been making changes to the database, and obviously this gets far worse as you have a team of developers. But it's time to push changes from development into testing. I've got this potential scenario here where the developers don't actually know which version is the latest copy of the application, the latest copy of the database. This whole idea of well, which one do we push forward? Obviously, if we push the wrong one forward, then we're screwed. And this is the kind of thing that can be removed and just doesn't happen if you're source controlling your database. So it's fairly common. I would almost go far as say it was second nature for application developers to be source controlling their work as they go along. And really there should be no difference with databases as well. So as we've just seen from this potential scenario, if you're source controlling your databases, if everybody in the team is source controlling a database, it enables you to have a single authoritative source for your schemas. It lets you see who changed what, when, and why. So you can build up a story of how the database ended up in the way that it did. It obviously gives you the ability to very quickly and very easily revert to a previous version. And this point goes hand in hand with the previous point. You're not just reverting to a version. It's not like a stab in the dark that this version might be the correct one. You have a history of what's happened. And if a bug's arised or something else that you need to change, you can very quickly go back to the revision that you need to. It also makes working in a sandboxed environment much easier as well. I guess one of the kind of questions over distributed development, other than cost, is how do we manage all of these changes? How can we give every single developer their own copy of the database or their own copy of the schema, let them make changes, let them experiment? How do we record and how do we manage all of that development? Well, if everybody's checking changes into source control, again, it enables you to do that because you have this single authoritative source for your schema. So as I've just mentioned, source control tells the story of what happened for a particular development, a particular branch of development. I've got a little table that I put together here, which is the kind of output that you get in most source control systems. We can see that I've made some changes. I've added a new table. Tom Kite's come in and he's added a trigger to email him when a new partner joins. So this is for a new feature of a particular application. He's pushed these changes through. We can see by the time at the end of the day he's come in the next day and actually it hasn't worked, or there's a bug in that, so he's able to fix it. Cary's come in and said, well, look, you should have profiled the app in the first place, and I've profiled the app and I found there's a bottleneck in this trigger, so I've removed it. And actually what is quite funny, if you Google Tom Kite and triggers, you'll see some great information about Tom used to be a fan and is not necessarily a fan of triggers, but that's a side story. And we've got another developer here called Neil who's just fixed another bug. These messages are all quite descriptive, and at any point in time we could go back to this log and see how this particular application developed, how the database side of this application developed, and how things got in the way that they did. So it helps us tell a story. That's important for going back and troubleshooting, but it's also important when it comes to deploying changes. You shouldn't be deploying changes blind. You should understand why the database is in the way that it is. And again, all of this history enables you to do that. There are, of course, some challenges with database source control over application source control. Firstly, you need to generate files. You can't just source control database objects. So you have to create files that represent your database. Then there's a problem of keeping those files in sync with the database and persisting data in deployments. And really for source control to have full advantage of many people checking in changes, you might want to consider setting up sandbox development environments as well. Although in terms of telling the story and then being able to revert back to changes, this is something that applies to shared development as well as sandbox development. So Redgate has designed a tool called Source Control for Oracle, which we're going to see in a minute. And the point of this tool is to make database source control easy. Things like converting objects into files, so exporting objects, converting to files, and then put them under source control. With an application like source control for Oracle, it really is as simple as writing a log message and clicking a button, and we're going to see this in the demonstration that I'm going to do. Keep on working as normal. You don't have to work in a different way. Just keep making changes. Let the software monitor the database and the source control system and enable you to keep those in sync. The table that I showed a couple of slides ago was just a representation of the kind of thing that you see in most source control systems. Source control for Oracle has brought that into the application as well. So all within one application, you can check changes in, you can see a history, and you can also get the latest changes out of source control. And there are some really cool features as well that we'll see that enable you to compare source control to database, actually do a side-by-side diff. If you're working on a shared development environment, it gives you the ability to lock objects as well. So in a way, it enables you to do the kind of things that you can do in a sandbox development, make some changes in isolation, and then check those changes in. Okay, so I'm going to bring my machine over now and show you source control for Oracle. I'm going to go through a couple of different scenarios and try and highlight where source control for Oracle fits in. The first will be looking at a sandboxed environment, and this diagram here shows you that source control for Oracle sits with each client. The developer will make changes on their machine and then use source control for Oracle to check those into a shared repository. But it's the same with shared development. Everybody's making changes to the database, and again, source control for Oracle is providing that link between the database and the source control system. And that's the important thing to remember. This product isn't a source control system. It's not a replacement for your existing source control system. It just enables you to source control your database, so it provides the link between the database and your source control system. Okay, so let's have a look at the product. Okay, so hopefully you can see that okay now. Yep. Okay, so this is the interface for source control for Oracle. It is a desktop application. I know it does look like a web app in a way, but it's a desktop application. And I've got a couple of projects set up here. So if you remember, the first scenario that I want to simulate is developers working in a sandboxed environment. Now, normally developer 1 and developer 2 would have their own copy of source control for Oracle on their machine. For the purposes of this demo, I've just created two separate projects here. Okay, so let's see what we've got here. So we've got an Oracle database called Obstacle, we've got a widget dev schema, and we've got it connected to a share repository. And we can see the status here that everything is up to date. I'm going to stick with developer. I've got a couple of scripts that I've pre-prepared. I'm just going to run this script here, and this is going to make some changes to Obstacle. Source control for Oracle is now going to poll the database for changes, and it's looking, if you remember, it's looking at, are there any differences between the database and the repository? And that script that I've run has made 5 changes, so it's telling me I've got 5 changes to check in. If you can see the bottom of the screen, you might be able to see the icon for source control for Oracle also has a little red dot on it to indicate that the database and the source control system are out of sync. So we'll click on here, and we've got these 5 changes to check in. So this is great. One of the items on that screen that I showed you with the log message, the last one just said fix bug 105 or something like that. If your source controller changes, you're able very easily to go back and actually look in the history. This is obviously, I've set this up for demos and stuff, but again, you can go back and you can actually find that particular revision and see object by object what had changed. And we can see this in the side-by-side diff here. So whether we're looking back at changes or we're looking to check in new changes, source control for Oracle gives you the ability to really clearly understand what's going on. So we're quite happy with all these. We've made these changes ourselves. We're doing a little double check just to make sure what's going to happen, particularly with some of the objects that we're editing rather than the new ones. And let's just type a quick log message. So I'll just call that fix bug 105, and we check those in. As I mentioned before, checking those changes into source control is as simple as writing the log message, clicking the check-in button. And now database and the source control system is up to date. Okay, we're going to go into this project here now. So now, if you think of me that I'm developer number 2, so everything seems to be up to date. I'm just going to refresh this. But actually, because developer 1 has checked some changes in, things aren't in sync. So there are some changes that are in source control that are different to what I have in my database, and that's why we're looking at the get latest screen as opposed to the check-in screen. So before I commence work, I want to get these changes. I want to get these changes out of source control. So now that my database is up to date with everybody else's changes. And as before, I'm just going to run a quick script here, which is going to make some changes for developer 2. And in the same way, source control for Oracle will poll the database. It will highlight this new change that I've made. Once again, I can look at the side-by-side view. Are there any differences? And then I can make those check those changes into source control. So I hope that gives you a bit of an understanding of how you can very easily share changes and check changes into source control. The feature that I wanted to look at very quickly, I'm not going to set up a new project, but if developer 2, if this was a developer working on a shared environment, we're using source control, and we wanted to work on some objects in isolation, then we can use this tab here, which is the lock object tab, and this will enable me to lock a few objects here. I can type a reason of why I'm locking those objects, and I can lock the selected objects. So they will now appear in this top screen. If one of your team members locks an object, it'll be indicated by a red padlock. If you lock an object, it'll be indicated by a green key. We've designed this feature as a communication tool, really. If I was to try and edit one of these objects, it would pop up a little aura message saying that this object has been locked by James or by my team member, and then it will give you the comment that I just inputted here. But anybody can unlock an object, and that's obviously very important. We don't want to lock people out of the database. We just want to enable people to communicate with each other. I'm working on these objects. As soon as I check these objects into source control, once I've been working on them, I can unlock them, and everybody else can carry on as normal. So the next thing that you might be thinking is, how does source control for Oracle actually help me then deploy those changes from source control into testing? Well, it's actually source control for Oracle can do that. It can compare the database and the source control repository. But there is a better tool to do that within the Redgate tool suite, which is Schema Compare for Oracle. The reason it's a better tool is it gives you the deployment script. Rather than with source control for Oracle is about managing those changes in development, checking them in, and getting the latest changes. Schema Compare for Oracle has been designed to deploy changes. It can deploy changes from source control. It can read script folders. It can obviously do the comparison between databases as well. If you want to find out a bit more information about that tool, then go to redgate.com/Oracle. Okay, so just to summarize my part of the presentation. So source control has lots of benefits, in particular the ability for you to tell a story about your database development, to record everything that you're doing as you're doing it. It also gives you the ability to revert to a previous version very easily, and again, gives you that insight of what has happened. just like your application, your database should be in version control. There really is no reason why it shouldn't. Previously, it may have been difficult to do. You may have to employ a lot of manual processes. It may have been a bit of a cost to the environment to set that up. As you can see, using a tool like Source Control for Oracle really helps out in this area. If you want to find out more information, you can also, and download a 28-day trial, please go to redgate.com/Oracle. Okay, so we're going to move on to the Q&A. A few questions have come in already. I hope both of the presentations were useful. I'm just going to run through these questions now. So please give me a little bit of time just to quickly have a look at what we've got here. So the first question is for you, Cary. And this question is, what are your thoughts on Oracle's DBMS_profiler? It's been used before and it's extremely helpful. But what are your thoughts on this particular?
Absolutely. Yeah, DBMS Profiler is it's a tool that shows you line by line in your PL SQL code how much time each line is consumed. And generally, that's not the first tool we use. The first tool we use, we do the instrument trace and then profile the trace thing. We will, when we see that PL SQL block during the execution phase, the Oracle execution of a PL SQL block is where most of our time went, then DBMS Profiler is the drill down to find out why the individual lines in that block contributed the way they did. So it is, it's step 2 in some cases where we see that PL SQL execution time is what is the top, the top time contributor as displayed in our profile. So it's basically a sub-profiling tool that allows you to drill in a little bit more deeply into PL SQL specifics when you have previously learned that PL SQL specifics are where you need to be pointing your attention.
Good. Thanks, Cary.
You're welcome.
Next question is for me. Is the premise of Source Control for Oracle that each developer has their own database? It's not. I mean, the tabs obviously has been designed to give you the ability to work in both ways. Possibly a question for our designers maybe is in terms of sort of hiding tabs depending on what environment you're working in. If you're working in a sandbox environment, then you do benefit from the ability to check changes into source control and then to get changes out and apply them to your copy of the database, or if you may actually be working on a private schema on a shared database. But if you're working on a shared database, that last feature that I show you, I hope highlighted, that you have the ability to lock objects as you go along. But I think the main point of using the tool in either environment is it gives you the ability to record these changes in source control in a very easy way. I hope that answers your question. Next question, what language is Redgate software written in? It's a Windows application, so it's a .NET application. The next question on, again, with source control. We have mercurial. I probably should have highlighted at the beginning of my presentation. Currently, source control for Oracle only supports Subversion and Team Foundation Server. But this question is actually to do with if you make context-specific changes to the PL SQL, will it show up in side-by-side diff? Yes. I mean, for the objects that source control for Oracle supports, if you're making changes to the object itself, that will be highlighted in the side-by-side diff. But unfortunately for you, it currently doesn't support mercurial. I've got another good question here, again on source control for Oracle. How would it handle non-object changes, things like reference or configuration data? Currently, it doesn't handle differences in configuration or reference data or table data. It is specifically designed for schema objects. We do have a SQL Server product that does a very similar job that does support reference data. So I guess it's just something that we need to develop, and it's certainly something that we would be looking to add to the tool in the future. Another good question here about source control for Oracle: how does it handle conflicts when more than one developer makes a change? It does handle conflicts, or rather it does pick up conflicts, and it gives you the ability to choose which version of the schema you'd like to take. So either your own copy or the database, or rather the source control copy. So it'll give you the ability that if you've made changes and in the meantime somebody else has checked those changes into source control and there is a conflict, it will highlight that conflict and give you the ability to select which one. It doesn't do an intelligent merge, but you will be able to do that through your own source control system. At least it highlights it and gives you the ability to contact the person that has made that change by looking through the history and then maybe working together on resolving that conflict. So a question for you, Cary. Do you think in the future we will have non-invasive instrumentation for PL SQL similar to Aspect J?
I doubt that Aspect J is truly uninvasive. It's hard for me to predict what Oracle is going to do with regard to different instrumentation strategies and tactics with their languages and tools. They've done a good job because they're a huge company, and obviously performance is important to them. It's a very integral part of their marketing strategy. So the product development team does a good job reasonably quickly in responding to ways that they can make their software faster. And making software faster is not just writing faster code, it's actually writing better instrumentation so that over time they can write faster code. So my answer is probably, but yeah, let me stick with the word probably.
Okay, a general question here: how do we obtain the presentation material? We will put a copy of the slides online with the recording as well, and I'll email everybody as soon as the recording is up online. I'm usually quite quick at doing this. With any luck, I can get the video online tomorrow. If not, it'll certainly be on Monday. But I will email everybody when the video is ready to be downloaded or rather viewed on the Redgate website. I've got a question here on source control of Oracle. Does it handle all kind of schema objects such as Java classes, wrap PL SQL, package code? There are a number of objects it doesn't support. For example, so it doesn't support Java classes or wrap PL SQL packages. I guess the best way to look at all of the objects that it does support, if you go to redgate.com/Oracle, navigate to the source control page, you'll be able to find out exactly what source control for Oracle does support, but it supports obviously all of the main objects, and particularly those that be changing regularly on the schema side. So thank you for everybody for your feedback in terms of that you've enjoyed the presentation. Please do obviously ask your questions to Cary about instrumentation and to myself about source control. We'll be looking to wrap this session up in a few minutes. A question on Redgate's source control. Does it capture changes from any interface to the database from the client? So I hope I'm correct in understanding this question. Okay, yeah, example, SQL developer. So indeed, so source control for Oracle is not looking at your development environment. It's not looking at SQL developer or Toad. It's looking at your source control repository and your database. So you can carry on making changes to the database with any way that you normally would do. It's actually one of the reasons that we decided to create a standalone application, is because there are obviously three main IDEs: SQL Developer, Toad, PL SQL Developer. A lot of people are also using SQL Plus, Some people using other products, Microsoft Visual Studio. It just enables teams to make changes in the way they normally would work. It's providing that link between the database and the source control repository. And source control, where is it storing the repository? Is it using another Oracle database? No, it's not. So the repository that I was showing was actually a Subversion repository. So I created a project and I'd link that into Subversion. Currently, it supports Subversion or TFS. So once again, it's providing that link between the database and your existing source control system. Okay, thank you once again for joining us for today's session. I hope it was useful. We've got some feedback in to say it was, so that's really great. I'm pleased that it was a good combination of topics. Thank you for that point. If you do want to ask us any questions afterwards, please do contact us. Follow us on Twitter. Contact Cary via the Murtagh website. Contact me via the Redgate website.
James, I'll mention one thing. I didn't catch this in the slides, but don't try to use the www in our URL. It won't work. It's just murtagh.com.
Okay, so apologies for that, Cary. So, yep, murtagh.com, redgate.com will work as well. I'll also put the video up on allthingsoracle.com. There is a comment section there as well if you want to ask any questions. So, thank you once again, everybody, for joining us for today's session, and thank you, Cary, for helping me present these two topics. I hope it was useful for everybody. I'm going to sign off now, so I wish everybody a good day or a good evening, depending on where you are in the world. Thanks, Cary.
Thank you, James. I appreciate being involved.